All right, I know this is a really fun lesson. It's also a little overwhelming, all the information you actually have to know. So if you're a little flustered, here we go. I'm going to work through the whole thing. Day one of quadrilaterals. And we need to know a few things. Before we even start the question, I'm going to make it in some blank space here. We need to know how to make the tree. We have quadrilaterals lead to trapezoids and kites. Trapezoids lead to isosceles, trapezoids, and parallelograms. Those two create rectangles. These two create the rhombus. And eventually we get the square. You must know the first time your core properties occur. I'm not going to write every property on this tree, but a few of the big ones is the kite has perpendicular diagonals. Isosceles trapezoid has congruent diagonals. Parallelogram, the diagonals bisect each other. I'm not writing all that out, but the diagonals bisect each other. And on a rhombus, the diagonals bisect the vertices. There's other things that go on, but those are like the core, like I would say, new ones. There's a lot more properties than that. But those are the newest ones that we've talked about. Most of the other ones, I think you guys know those properties a little bit better. So keep that in mind as we do these. And actually, before we answer these questions, because they're all the same choices, I'm going to go through each one of them and talk about when we first see it. So when do we first see four sides? Well, that's just a general quadrilateral. When's the first time opposite sides are parallel? That's the parallelogram. Diagonals are congruent. We just said that. We get that on the isosceles trapezoid. The diagonals are perpendicular. We get that on the kite. And then we have diagonals bisect the vertices. When do we get that one? That's the rhombus. The diagonals bisect each other. That's another one of the core parallelogram properties. Opposite angles are congruent. Another core parallelogram property. All angles are congruent. The first time the angles are congruent is a rectangle. What about a square? What about a square? I know. Calm down. The square has four congruent angles. I agree. But look at this. Would you call that a square? No, you wouldn't. Does this have four congruent angles? Yes, it does. When I call something a rectangle, it doesn't mean it's not a square. As a matter of fact, if I call it a rectangle, there's two things classified as rectangles and squares. So calling it a rectangle means it might be a square. Yes, you're right. A square also has that property, but a rectangle is the first time we see that property. So if that's all you know, then it might be this and not be a square. Consecutive angles are complementary. Did we talk about that at all? No. Consecutive angles are supplementary, was a parallelogram. That's one of its core properties. Opposite sides are congruent. Parallelogram, one of its core properties. And all sides are congruent. Think. Did you say square? Did you say square? Rashab, did you say square? Who said square? It's not square. It is rhombus. Rhombus. Now it happens in a square too. The square. I know, guys, calm down. I know that it's true on a square, but it's true on a rhombus first. Now, what happens when this property combines with this property on the rectangle? The square has both of those. If you knew that both of them are true, you would know you have a square. Okay. So the first question here is which properties first appear in the parallelogram? Put them in order they appear in the list. So we're going to go through and I'll do all the parallelograms. That's option number 2. Opposite sides are parallel. That is option number 6 is the next one. Diagonals bisect each other. Number 7, the opposite angles are congruent. And then finally, number 10, did I skip one? No, number 10, consecutive angles are supplementary. And then the last one, opposite sides are congruent. So there are 5 core properties on a parallelogram. And remember, if any one of those 5 occur, they all occur. All right, I'm not going to do that on all of these. We've already talked about which ones are which. This is the same thing, but for the rhombus. Do you remember which ones are for the rhombus? There's only 2. Number 5 is for the rhombus, and number 12 is for the rhombus. That's it. So number 5 and number 12, that's it for the rhombus. That means the rest of these blanks you need to put in there no more. No more. There are no more unique properties besides those 2. For the rectangle, there's only one property on this list that happens for the first time in the rectangle, and that is number 8. That means the rest of these are no more. All angles are congruent on the rectangle. That's the first time we see that. Okay, sometimes, always, never questions. These are a challenge, guys. They're hard. I'm going to make the tree again. Quadrilateral goes to trapezoid. You should try to do this from memory right now. Parallelogram, those two make the rectangle. These two make the rhombus, and those two make the square. So that's going to help us answer these. Rectangles are trapezoids. So rectangles, these two shapes are rectangles, and I like to circle things. Different teachers teach it different ways, but these are my rectangles, and these are my trapezoids. Are both rectangles on the list of trapezoids? If I made a list of all the trapezoids, would I list those two? Yeah. Rectangles are always trapezoids. Now, are there other trapezoids that are not rectangles? Yes. If I said trapezoids are rectangles, that would be sometimes. But rectangles are trapezoids, that is always. Both of these shapes are inside the trapezoid circle. So, rectangles are trapezoids, always. A parallelogram with one right angle is a rectangle. So let's think about this. If I were to draw a parallelogram, now I'm not going to get this perfect, but, well, never mind. I kind of did, didn't I? Sometimes you're just good. Okay, so let's say one of the angles is 90 degrees. Let's say this guy's 90 degrees. Opposite angles are equal, so now that's 90 degrees. Consecutive angles add up to 180. So like if this is 90 and this is 90, well, these two corners have to add up to 180. So now that's 90. And opposite corners are equal. Now that, guys, so if you have one right angle, is it a rectangle? Yeah, always. All the angles are right angles now. And I need to remind you that in math, when we say we have one right angle, that means with at least one. That is implied. That means, hey, we know for sure one of these angles is 90 degrees. We don't know about the rest of them, but we know it's a parallelogram, and somehow, some way, we know this corner's 90. We're not going to speak to the others, but we're going to say we have a parallelogram with one right angle. That's what we know we have. We might have more. You need to read it that way. A quadrilateral with no right angles. Let's think about that. Where are the right angles? Boom, boom. Those are the shapes with right angles. So a quadrilateral with no right angles could be any of these. So anything I circled in purple, actually, we can include the top. Anything I circled in purple fits that description. So a quadrilateral with no right angles and congruent diagonals is a rhombus. Well, where do we get congruent diagonals? This gets real confusing. This is my congruent diagonals. So here's my shapes with congruent diagonals. Here are my rhombuses. Let me maybe remake this circle. It might be a little bit easier to understand. So let me redraw. So here are the shapes with congruent diagonals, these three. Here are the shapes that are called rhombuses. Where do they overlap? They overlap at the square. But listen, they said it has no right angles. So we can't say square. So a quadrilateral with no right angles and congruent diagonals, can that ever be a rhombus? Nope, never. Nope. Now, if we took this out, if the no right angles thing was not there, if I just said a quadrilateral with congruent diagonals is a rhombus, if that's all I said, that would be just these shapes, and yes, that sometimes happens, right? A square is both of those things. So I know that's hard to understand. We're going to keep practicing some of these things. Let's go back over here. So a quadrilateral with no right angles and congruent diagonals is a rhombus. That is never. The diagonals of a parallelogram bisect each other. Always. That's one of its core properties. The rhombus is a trapezoid. Okay, so here's the rhombus. Actually, both of these are rhombuses, right? Here's the trapezoids. Is the rhombus part of the trapezoid family? If you listed everything here that's classified as a trapezoid, would you include rhombus and square? The answer is yes. So every single rhombus is always a trapezoid. A quadrilateral with exactly two 90-degree angles is a trapezoid. This is a thoughtful one. So can I draw a trapezoid? Well, let me do it. Nope, it's not gonna let me do it. Okay, so I'll just kind of, I'll do the best I can. What am I doing? I want to go that way. Okay, so we got a trapezoid. Can we have one right angle? Yep, we can have one, but can we have exactly one? No, if that's 90, this is going to be 90. So it can definitely happen in a trapezoid. Could it happen in a shape that's not a trapezoid? Could I have one of my favorite shapes called the kite? So if this was a kite, remember these two sides would be equal, these two sides would be equal. And if this side was 90, like if this is my line of symmetry, could it reflect over here and this be 90 as well? So could a kite have exactly two 90-degree angles? Yes, it could. Could a trapezoid? Yes, it could. And there's actually other shapes that could as well. So can you have exactly two 90-degree angles? Is a trapezoid? That's going to be sometimes. The diagonals of a rhombus are perpendicular. Perpendicular diagonals is a core property. Where do we get perpendicular diagonals? It's right here. Perpendicular diagonals. That means all of these have perpendicular diagonals. So what was the actual question? I forgot. The diagonals of a rhombus? Yeah. So a rhombus is a direct descendant of the kite. So do rhombuses have perpendicular diagonals? Always. They are a type of kite. The diagonals of a quadrilateral are perpendicular bisectors of each other. So here's perpendicular. Where do the diagonals bisect each other? That's parallelogram. Diagonals bisect each other. That's parallelogram. So all of these shapes, they bisect each other. All of these shapes, they are perpendicular. Which shapes have both properties, rhombus and square? So a rhombus has that, a square has that. What are they saying? Then the shape is a square. Ooh. So let's talk about this. The diagonals of a quadrilateral are perpendicular bisectors. That is code for rhombus, right? If I said, tell me what shape that is, you would have to say rhombus. Rhombus could be a square, but doesn't have to be a square. I can draw this situation with a rhombus without making it a square. So I know it has to be a rhombus, but that means it might be a square. So this question can basically be transformed into a rhombus is a square, and that is sometimes. A rhombus is sometimes a square. A quadrilateral with three right angles is a rectangle. Ooh, if I have three right angles, what has to be true about that fourth one? If that's 90, 90, and 90, 360 minus 270 is another 90. That fourth one would have to be 90. So if three of them are right angles, then they're all right angles, and it has to be a rectangle. The diagonals of a quadrilateral are congruent and perpendicular. So we have the diagonals of a quadrilateral are congruent and perpendicular. Diagonals are congruent and perpendicular. What shape has both properties? It's a square. So the diagonals are congruent and perpendicular. That is code for a square. Then the shape is a square. Well, is a square a square? Always. Woo! Tough questions. I know, guys. All right, now we're going to use the properties to solve situations that come up. This says rice is a rhombus. IX equals 10. IC equals 12. How long is RC? What is the measure of angle RIC? Round to the nearest thousandths. So, things we know about a rhombus. We know that the diagonals are perpendicular. Find the right triangle. That's your job. Some shapes, it's a lot easier than others. This shape has 4 right triangles. So I'm gonna make it blue. This triangle here, I'm gonna draw it upwards. But what do we have? We have 10 and we have 12. If I call this little angle X, or actually, which angle do they want? They want angle RIC. Okay, well, I'm gonna call that angle X. Let's get that first. How would I do that? That would be X, this would be adjacent over hypotenuse, so the cosine of X equals 10 over 12. So X equals inverse cosine 10 over 12. What is another core property of the rhombus? Well, If that is x, this is also x. On a rhombus, the diagonals bisect the vertices. That means that this corner is cut in half. So how big is the angle we want? It's going to be this number times 2. So when you go and type that in, let me make sure I got this right. It'll be 2 times the inverse cosine of 10 over 12. And I get this answer, 67.115. Okay, so we got that angle. How long is RC? I'm going to call this side y. I know 2 sides. I can actually just do Pythagorean theorem. Because I know the hypotenuse, I'm going to do the square root of 12 squared minus 10 squared. The square root of 12 squared minus 10 squared is 2 root 11. So this is 2 root 11, but on a rhombus, because it's a type of parallelogram, the diagonals cut each other in half. So if that's 2 root 11, this is also 2 root 11. You have to know a lot of properties to get these right. The main thing that helps me remember on a rhombus is that we have 2 lines of symmetry. This diagonal is a line of symmetry. That means that this side lands here, this side lands here, this angle lands here. When you fold it over that line, you can see a lot of things that happen, but that also means that these 2 parts would be equal. But a rhombus actually has 2 lines of symmetry. This is also a line of symmetry. We didn't need it this time. But this angle would land here. Like we could go that direction as well. We would know this is also 10. These are all properties for the rhombus. We've talked about that. But RC would be 4. RC would be 4 root 11. But we want to round to the nearest thousandth. So 4 root 11. Make sure I got the right answer. Is 13.266. Nailed it. Nice. Nice, nice, nice. You can look at all that. Moving forward. Next shape, rectangle. Again, knowing the properties that apply. Let's talk about it real quick. We know that the corners are 90. Oh, I wonder if that matters. Spoiler, it does. We know that the diagonals are cut in half, so those are going to be equal. I know that the diagonals are congruent, right? This is like, let's go look at the tree. If the diagonals are congruent here, then they're also congruent there. So rectangles have congruent diagonals. So whatever UD is, QA is going to be the same number, and they're both cut in half. For instance, I don't know what it is, but let's pretend that UD equals 20. Well, if UD is 20, this would be 10 and 10, and that would mean that QA is also 20. Okay. I don't want to get too confusing in the video here. All right, angle USA is 40 degrees. USA, 40 degrees. The length of UA equals 8. Find the measure of UDA, and the length of US. Okay, we can do this. We got this. Because of all these properties, we actually have a lot of little isosceles triangles. If that's 40, let's fill out the rest. We got 40, 140, 140. This triangle is isosceles. So if that corner's 40, you do 180 minus 40 divided by 2, and these are going to be 70s. These are going to be 70s. And then on the other ones, if the whole corner is 90, these are going to be 20s. There's a lot of ways to get there, but every corner is either 70 or 20. We want to know how big is angle UDA. Well, that's this 20-degree angle down there. Remember, we go in order. UDA. UDA draws that 20-degree angle. So UDA is 20 degrees. How long is US? US is this side right there. So this is what I'm actually going to do. I'm going to go a little bit big. I'm going to work on this triangle. So let's see what that would look like. If I make that triangle, I know this side's 8, this angle is 70, and I am going to call the hypotenuse X. Why am I doing that? Well, if I can get the full length from U to D, how long is US? It's half of that. And that's a property of parallelograms, right? The diagonals are cut in half. So on a rectangle, they're also cut in half. So let's get the full thing first. This would be adjacent over hypotenuse. So this would be the cosine of 70 equals adjacent over hypotenuse. I could have used the 20-degree angle as well, and it would have been sine, just so we remember. If X is down low, they switch places, you know. You got to get tricky with it. So that's what the whole thing is. But I need to divide that by 2. What would be 8? What would that be divided by 2? Think hard. If you said 4 over cosine 70, you are right. Or you could have slapped a 2 down here, right? Like to divide by 2, you put a 2 in the denominator. But that's what it would look like. Or if that's hard to understand, remember dividing by 2 is the same as doing times 1/2. We've talked about that. Division and multiplying by the reciprocal are the same operation. But 4 over the cosine of 70 is what I'm looking for, and that's 11.695. Boom, 11.695. Got our answers. The length of O is 15 root 2. Oh man, this is a square. This is a square. So if that's 15 root 2, then this is 15 root 2. That means this whole thing is 30 root 2. Let's look at this triangle. Do you see this triangle? If the entire thing is 30 root 2, what are our rules? 1, 1, root 2. Why am I doing that? Oh, wow, I don't know. It's a square, so these are 45s. Every triangle you see are 45, 45, 90s. We know the corners are 90 degrees because it's a rectangle. We know the corners are cut in half because it's a rhombus. So if they're 90 degrees and they're cut in half, then they're 45s. We know that the diagonals are cut in half because it's a parallelogram. We got it all going on. Well, how do we go from the hypotenuse backwards? You divide by root 2. That means these two sides are going to be 30. 30 and 30. So what is the measure of my PAL? Ooh, where is that angle? Let's draw it real quick. PAL. That's going to be a 45-degree angle. What is the area of the square? Well, the area of a square equals the side squared. That's where the term squaring comes from. Interesting. Area equals 30 squared, or 900. 45, 45, 90 rules. 45, 45, 90 rules. You better do it. If I see sine, cosine, or tangent on that, I might have to kick you in the shins. Don't make me find your shins. All right, question number 8. It says WXYZ. WXYZ. Oh, dang. Woo! Okay, it's a kite. And you know what happens in a kite? Kites must be right. They got to make these perpendicular lines. They got to. Guys, I'm going to zoom way up. Let's go. Keep moving, moving, moving. Perpendicular diagonals. That's the core thing that the kite brings us. The other thing that we didn't really talk about is we have a line of symmetry. So if they tell us that yx is equal to yz, where's my line of symmetry? This blue line must be my line of symmetry. That means that it's reflected over that line. That means this side's going to be equal to this one. That means this angle is going to be equal to this one. And we're going to keep going and going. We don't need every little detail. But it's a line of symmetry. Okay, so working with that, the measure of angle XYZ is 60. This entire corner is 60. But because of the line of symmetry, it's going to cut that angle in half. It's folded in half. That would mean, because that's a 30 and that's a 90, this would be 60 and 60. Boom, I'm just going to town. V-dubs is 12. YX is 10. Find the perimeter of the kite. Okay, well, this is going to be 10. 30, 60, 90 rules. I'm going to change colors here. 30, 60, 90 rules. That's the hypotenuse. Divide by 2. This would be 5. And that would make this 5 root 3. And this would also be 5. How do I know all these things? Well, 30, 60, 90 rules. 1, root 3, and 2. Divide by 2 times root 3. That's how I knew those. This is a line of symmetry. So these two things have to be equal. You got to know your kite rules. All right, and if this is 5 and this is 12, then I know that these are going to be 13. Oh, that's pretty cool. So what's the perimeter? The perimeter is going to be 10 plus 10 plus 13 plus 13, 46. How big is angle YXW? Where is that? YXW. It says round the angle to the nearest degree. So before we work on that, let's look on this small triangle right here. So I'm going to take the purple triangle off to the side. We have 5, 12, and 13. I'm going to call this X. Since I know all three sides, I could use sine, cosine, or tangent. I'm going to use tangent. We know that the tangent of X equals opposite over adjacent. So we know that that angle is the inverse tangent of 12 over 5. So that's how big this angle is. And this angle over here is 60. So how big is the entire corner? So the entire corner will be 60 plus the inverse tangent of 12 over 5. Let me type that bad boy in. 60 plus the inverse tangent of 12 over 5. And I get that 127.380. But it says round to the nearest degree. That's going to round to 127. ABCD is a trapezoid. It is not drawn to scale, not even close. The top base is 102.5. The left is 27.56, and the right side is 13.25. It is not marked clear in the picture, but the 102.5 is the entire top. So this is the 102.5. How long is the mid-segment of the trapezoid? Ooh, that's a new word. It tells us right here, a mid-segment is a segment that connects the midpoint of the two non-parallel sides of the trapezoid. So midpoint of the two non-parallel sides, there's a mid-segment. Its length is the average of the two bases. So it'd be base 1. So another way of writing this, its length is base 1 plus base 2 divided by 2. That would be the average of the two bases. So that's how long the midsegment is. So we need to get the length of the bases. I'm thinking. Okay. Do not round. Type in the decimal form of each of the answer, which goes to the thousandths place. All right. I see a trapezoid. I am going to cut off its wings. Ouch! The trapezoid says. That's okay. We're going to cut its wings off. Anytime you have a trapezoid, not anytime, but a lot of the time you have a trapezoid, you want to make two right triangles and a rectangle. So this middle section is going to be 102.5. Now the key here, and I'm getting real messy, I'm actually going to erase my mid-segment for a second because it's hard to see, is this height is 10.6 on both pieces. So if these are both 10.6, we're going to work on two separate right triangles. So we got the left right triangle, I'm going to draw it down here, where you have 10.6 and 27.56. So can I call that x, that little piece x? That's going to be the square root of 27.56 squared minus 10.6 squared. I'm just going to leave it like that. I'm going to let that sit for a second. Okay, over here we have another right triangle with 10.6, and this time the hypotenuse is 13.25. So call this side, this little piece y. That's going to be the square root of 13.25 squared minus 10.6 squared. Okay. So if I add those together plus this, plus 102.5, don't I get that entire bottom? All right, so I'm just going to kind of type this in the calculator, but what am I doing? I'm doing this number at the top plus all three of those. So that's base 1 plus base 2, and then what am I going to do to that answer? I'm going to divide it by 2. So I'll show you my screen in a second, but I'm going to do 102.5 plus the square root of 27.56 squared minus 10.6 squared, all of that plus the square root of 13.25 squared minus 10.6 squared, and then plus the top would be another 102.5, all divided by 2. So it actually does come out to an exact value like it said. So I started my fraction. I did 102.5, you can see everything in there. I added the first Pythagorean theorem we did, plus the second Pythagorean theorem we did, plus the other base, all over 2 to get the average of the bases. So we have a final answer of 119.195. One more question. I did not realize this was this long, so maybe a little bit much for one night, but that's okay. You guys are strong people. East is an isosceles trapezoid. Oop. The measure of T, angle TEA, so this entire corner is 124. And ES equals 12, so this diagonal is 12. Find the measure of angle AST, that's this entire corner. So isosceles this picture is confusing, so I'm going to redraw it. Those diagonals are in there, and they don't need to be. They're just causing me problems. So I'm going to redraw it over here. We know this corner is 124, and because it's isosceles, base angles are congruent. That means we know every angle because these angles, they're same side interior angles. They use the parallel lines. They're going to add up to 180. These corners have to add up to 180. So how big is angle AST? This entire corner is going to be 56 degrees. And if they tell us that ES, if this diagonal is 12, then how long is the other diagonal? It's also 12. Let's scroll on up. Look. Isosceles trapezoids have congruent diagonals. So this is an isosceles trapezoid. If one diagonal is 12, then both diagonals are 12. Guys, that was a lot of fun. I hope you enjoyed those problems. They're like little puzzles, but you have to know a lot of properties. We're going to keep working at it. Love y'all.